Right, next up we have Peter Brown. Peter Brown's the General Manager of PSC New Zealand. Peter went to Canterbury University. I bet you he didn't develop electric vehicles and race cars back then, but Peter did go on to develop his own company that looked at engineering solutions for basically industry across New Zealand. One of those was the Shore technology, which many of the generators adopted. It was also then combined and picked up by PSC. And Peter's continued on at PSC, first of all taking on the Asia Pacific sales manager role, and very more recently stepping into his current role. So the stage is yours.
Thank you. So because I wander around a bit, I got the lapel mic this time. So firstly, Vic, that was awesome. Really great to see the future looking out, because 20 years away is sort of a big picture thing to keep an eye on. My presentation's about what's here now and what we're aware of now. And so I suppose we can see some specific steps that actually are heading in the right direction in accordance with what Vic was talking about. So I feel relatively new in the electricity industry. I'm not a 40-year veteran. And I was talking to some people the other day and realised that the Geoshore technology that we brought in and crossed over from the high-tech industry was about 10 years ago. So I'm not quite sure how long it takes to become not new, but maybe I'm getting into it. So if we click through. So what I want to talk about today is big to small and then back again. Large infrastructure going out to distributed systems, and a look at global, national, local, and then what I'll call sovereign individual sort of things, and convergence. So a number of those things are sort of threads that I'll weave together. So stay with me. It's a little bit like a mixtape in Guardians of the Galaxy. Some of it's a bit tongue-in-cheek, so stick with me. One of the things I'll talk about, though, is the music industry. So just out of interest, I'm a musician. I do things for fun. How many sort of raise your hand if you sing or play an instrument and you happen to be in that category? So that's quite a good proportion of the room. I see music over time as being quite a good analogue for what I see happening to the power industry. So let's go on to the next thing. So looking at a timeline, there's sort of three areas that I want to touch on. We've got the movie industry, TV, and music. So movies are kind of fairly similar to what happened in the 1960s. You still go to the movie theatre today. The next step down, you're talking about your TV. Yeah, you might have started life with a black and white pie TV built in Waihi, actually. Moving through, it looks pretty similar. The technology's quite different, and maybe it hangs on the wall rather than, takes up a big chunk of the lounge. And then the last one is the music industry. As we've moved through the different platforms and different things, it's all shifted and changed a bit, but it's cost people and changed the way people have made money out of their music. So I'll just jump back to the 60s. I mean, you might have turned that TV on at 6 or 7. Actually, you wouldn't have touched it. It would have been one of your parents has touched it because you weren't allowed to touch it because you were too young. And it might have been on for an hour or two and then turned off, and that was all fine. But if you wanted to go to the movies, you went off to see the Pink Panther with Peter Sellers. And, that was a family event. It was quite a special thing. Moving into the 70s, you've got a colour TV, maybe. By now, the programs are a little more interesting. And, some unknown guy in London releases a song and becomes a superstar. He used to be called Reggie, but he changed his name to Elton. Moving on to the next bit, you've got the IBM PC released. And into the 80s, you've got Commodore 64s and other things like that. So you've got music television, and that was another way to change the way that people thought about their music, what they did, and how they engaged their viewers. And all the way through this, those musicians, yes, you had to share information and share money with the record companies, but you made a buck. Moving on again, into the 90s, your computers got more capable, and you might be sitting at a desk with a computer that's more capable than you are one day. But then we get the music industry manufacturing pop bands. So they sort of come up and disappear again, that kind of thing. Into the 2000s, we broke the industry. So the music industry broke by the MP3. You could download the song, you could pirate it, and that was it. Suddenly, they couldn't make money out of that, and they had to change their industry. They got disrupted. So moving to the last bit was streaming, or streamed, it says there. So from that point of view, with the internet, things tended to free. So your music started being valuable and then tended to free. The movies tended to free. The TVs tended to free. And with the technology increasing, the bandwidth increasing, we've been able to transmit that information faster and better to the people who want to consume it. But you pay less and less for it. So you need a bigger and bigger audience to make the same money. So what those musicians particularly have figured out how to do is use that free technology to get to their fan base and then convince them to come along and buy a ticket to a live show. So if you're selling tickets these days, you're selling tickets for a big live show, and that's where most of the musicians are making their money. So if we jump to a different convergence, I'll just pick up on a cell phone or a smartphone. We've got a computer in our pocket now. It enables us all to be a sovereign individual. Now, by that, I don't mean we're all a king or queen of our own little country. What I mean is that economically, we can choose to interact and decide to do business with another individual or group or other area. So that enables us to consume and produce media, and you can create a superstar overnight, and probably more cat videos than anyone ever needs to see in their lifetime. So how long will it be, though, before we're trading surplus power using our cell phones? So what about convergence in our industry, in the power industry? So one example of that we're seeing is the convergence of connection studies or new generation coming along. So if you go back a few years, a developer looked at a wind farm and they built a wind farm. A developer looked at a solar and they're building solar. More recently, a few batteries have gone in, but now we're seeing combinations of those renewables going in to help solve some of the issues that are generated by them individually, whether that's voltage issues, system support, that kind of thing. For us at PSC, in the last few months, we've actually seen more than a couple with 3 or more of those at the same site. So that makes for quite a complex site. They end up with discussions around network support, and it makes for an incredibly complex system study. So that's what we see. Looking at other options, so we talked about network support. We're involved with a client over in the UK at the moment who has started a technical feasibility study about whether they can use their existing generation to using software control to provide some of that support. So rather than having to put in a physical piece of kit, we've now got software trying to solve the problem for us, allowing us to control reactive power in and around generation to provide that support and add more generation and more load to the network. If we jump back to the consumers for a bit, we've got consumers who are investing in their own assets. They want a bit of control. We've got data feeding from that to data and analytics, and we've got consumers now who are prepared to share. You know, it might not all be cat videos on Facebook, but we're actually prepared to share things. We've got rideshare, we've got scooters, all sorts of things where we're actually using that computer in our pocket to share information. And we've got the Internet of Energy, where various devices that we have are starting to connect up. You know, whether the fridge is telling someone what you want to buy from the shops, that sort of stuff is happening, and we're seeing it now. So a question there is, if we are seeing that sort of progress, instead of the next What's My Number campaign, what happens if the government says, oh, well, 3D printed solar panels just got below $1 each. We'll print out 100,000 of them, hand them out, and some people can plug them into their walls. Suddenly, we've got an ultimate distributed power system just sitting on people's roofs. There could be disruptions coming along those lines. No, wrong one. That one. So we're seeing other disruptions and other changes. So recently, we did some PSCAD modeling on an inverter technology at a grid scale that's got synthetic inertia. So you may have heard at various other presentations, there's a lot of worry about how the system strength is coping and what's going to go on with that. We can see digital control happening of that synthetic inertia, and eventually it'll come down to the 5 kilowatt inverter you can put in your house. Now, once we get to that point, maybe we can fix some of the network problems with application upgrades for that inverter. Almost, there's an app for that. And what we found going through that modeling with this supplier, we were finding issues. They would simply give us an upgrade to the software to fix the issues. There was no change in the hardware. So if you take that and you move beyond the meter and get in behind the meter, you're talking about smart appliances and the ability to share information or choose to share that information with your distribution company, with your energy company. So, I don't know, ripple control on steroids. If you were prepared to give up some level of control, maybe you didn't care that your dishwasher took 4 hours to go through, maybe 2 is fine, instead of 2. That might mean some load leveling, that might mean a little more control. But going back the other way, you might also allow them control of your inverter so that they can manage voltage, manage other things in your area. So how do you achieve that with the appliances? You know, Wi-Fi enabled appliances with their own microprocessor, their own computer inside. They're already here. So, some big names up there. So we've been doing a collaboration with Microsoft and ADGA Energy over in Europe. We're finding that collaborative projects are the new normal. So we're not just doing it ourselves. We've actually got to work together in an ecosystem. And it was interesting that Vic touched on that. So for this particular one, it's predictive forecasting for situational awareness using IoT. They're using the Microsoft software stack, and if the technology will behave, there's a little video that Microsoft put together about it. So I'll just throw that on.
Thomas Edison would feel right at home with today's power grid. It still looks a lot like the system he started building in the 1880s. But the world has changed a lot since then. The aging infrastructure of the grid today just can't keep up. The old linear model of large centralized power plants is inflexible and unable to predict usage or integrate new sources. At the same time, consumers are no longer simply passive customers on the end of the power line. Consumers have embraced the Internet of Things, smart appliances, and devices that are connected to the cloud. This opens the opportunity to change demand in real time, making the potential for a more responsive system. In addition, distributed energy resources, or DERs, are being installed in homes and businesses to generate additional sources of power. Consumers can now contribute back into the power grid. The grid needs to evolve from the days of Edison, but rather than start from scratch, a layer of software can be created over the top of the traditional infrastructure to help utilities create a better grid. This new system is known as a smart grid. In a smart grid, IoT connects all the new energy devices to the cloud, enabling the power company to take advantage of big data and machine learning. The resulting analytics can yield a power grid that more efficiently uses resources, is more resilient, and with less consumer cost. Smart grid makes sense in theory, but it needed to be put to the test in a real-life environment. So, Microsoft partnered with the Norwegian power provider ADGA Energy to launch a pilot smart grid program. Using a Microsoft Azure Intelligent Cloud and IoT technology, we provided Agda Energy with tools to manage the operation of new distributed energy resources, including device controls and predictive forecasting for situational awareness. A two-way flow of information and power means new resources now connect into a system that has orchestration and coordination. Demand is managed as a flexible dynamic force, not taken as a given, and is matched with supply when the energy supply is cheapest and cleanest. Software unlocks distributed energy resources, and the system becomes more than the sum of its parts. By empowering everyone to be a part of the smart grid, utility companies are providing better service and giving more choice to their customers, who can in turn respond to the needs of the grid, thus creating a virtuous feedback loop. It's a brave new world for energy, and we think Thomas Edison would be proud of where we're going with it.
So what we're seeing also there is companies who aren't traditional power companies getting involved with power. It's another thing to keep an eye on. So if we go a step further and look at some of the bigger ideas. So there's green hydrogen. So can you take your surplus energy, create hydrogen, use it later? If you're Australia, maybe ship it around the world to other people who want to use hydrogen. There's other ways. You may have also heard of a supernode. So the idea there is to connect Europe using HVDC all the way through. And my question is, well, if you could do Europe, could you do the world? So if you want to stretch it really far, and we'll forget about losses, because I know someone will say that's not going to work. If you had a bunch of solar panels on one side of the world, can you power up the other side of the world and just carry on around 24/7? So various ways to go. Being way down the bottom of the world, maybe not in New Zealand. Maybe someone can't be bothered getting a power cable to us, but we'll see. So if we take all those ideas and tie them together like a knot, or like a rope, we've got consumer energy assets, we've got the analytics, we've got that social economy, and we've got the Internet of Energy. And there's both a danger and an opportunity as to what happens next. Are the customers revolting? Is a question. And no, they're not revolting as in revolting against us, and they're not horrible. They just want to have choice. And I think that's what we're seeing as our customer base are younger, or the younger customer base are keen. So particularly if you're under 40, you're choosing to be social, you're choosing to be green. You want to have control of those data and devices, and you're choosing to transact with an energy sector that gives you a benefit for giving up control. So I suppose it's all about power, and we're here to make it safe and reliable and affordable. But my question to everybody is, do we want to be, Apple Power? Use Apple Power on your phone to trade energy? Do we want to be Microsoft Power? Maybe it's a bit more palatable to be Trade Me Power. But I reckon we've got, the Black Ferns, the Black Sticks, the All Blacks. Why don't we have Black Power? Oh, hang on, sorry. Someone's probably got that name. Maybe we should change it to something else. But if we could get together as a power and energy economy, and if we could build our own system, our customers are comfortable with microtransactions, they're comfortable with that sort of situation, and I think we could build something for them which enables them to do that trade of power. But I come from an engineering background. We can't just let it happen because it's not going to work very well. If we let it happen, either someone will, as Peter says, while we're blowing on our pie, someone will take our lunch. But what we do need to do is design it, and we need to architect it. So in my mind, the future's already here. We've got all the pieces, we've got everything. We've even experimented with some of the technologies. But we've got to get that reliability, the sustainability, and affordability. And I think we could work together, and then we could sell our solution from a couple of little islands on the Pacific to the world. So in summary, from big to small and back again, I think we're a great test bed. I think we have some great ideas and some great people to develop them. But I think as things become more distributed, as our customers decide they want a bit more control, they're becoming that sovereign individual. And we saw a little bit in Vic's presentation about what the next convergences and the next things could be. But I think we've got a few things we can do here as New Zealand to take it further. Thank you.
Right, we have some time for questions. Easy ones or tricky ones. Peter said he likes tricky ones in particular.
Oh, I don't know about that. I haven't seen Brian. I actually know, there he is. You went here yesterday. That's all right. Oh, okay. But you've had a few good questions today, apparently. I've got a question for you, Brian. Can we go that way around? Yeah?
So a question for Brian.
So this is a question for Brian. So if I was to walk up to you tomorrow, I haven't got my phone because I left it over there so it wouldn't buzz in my pocket, and I said, oh, look, I've got an extra 10 kilowatts over the next couple of days. Would you like it? Would you take that and buy it if the price was right?
10 kilowatts isn't much. My hydro scheme generates 1,000. Sorry about that.
No, fair enough. How about I've got a group of people who have got together in a group, and we're a neighbourhood, and we've got a bit more than your power station. Would you then take it?
You'd have to give me a good reason, because I want continuous supply. I want it to get work when I turn the switch. I don't care about controlling it, even though I do manage my own power at home. Mm-hmm. But most consumers don't. No, it doesn't grab me. It's something that should be there, just like roads and sewage and water.
Okay.
I've got a different view on it than you have, but that is my view.
Was that a yes or a no?
Well, I didn't get a yes or a no, but that's okay. So I'm not sure whether that's... does that mean that Brian's had his question and now I can move on to somebody else? No, I'm not sure.
Now it's my turn.
But that's all right. Hit me with it.
Okay. In all you say, it implies that all these new technologies are cheaper than existing. Mm-hmm. The evidence is the other way around. There's quite good research that shows the more renewable energy, wind and solar, a system has, the more expensive the power.
Correct.
And it's very substantial. The more central power stations they have burning coal, gas, or nuclear, the cheaper the power. Mm-hmm. And if you don't like coal and gas, France has the cheapest power in Europe and lots of nuclear. So everything that you're talking about can be done better and cheaper with nuclear power. Why aren't we talking about it?
Good question.
Why aren't we talking about nuclear power? Well, I'm pretty sure it started with Longy and some comment about uranium on your breath, wasn't it? If I've got that right. When he did the original discussion over in the UK. I still don't think that the population of New Zealand are comfortable with nuclear power.
But that's going to stay that way until we start pointing out that it's not true.
Okay.
It's our job to be telling them what they believe is not done.
Okay, good question. Do we have another question?
I'll just comment on something else that Brian said. So you said it doesn't make sense from a dollar's point of view, but a lot of things don't make sense from a dollar's point of view, but if the people do it, we've got to figure out a way. So sometimes more people makes it work better. It's a circular argument, I agree.
Very good. We've got a question in the middle.
Yep.
Yeah, just wonder if you've got any feedback, because there are some embedded networks and peer-to-peer trading that's already going on in New Zealand. We've got some in Wiper that's been done with a couple of developments there, so I just wonder whether you can share your experience learning that and how you see that experience helping to develop the concepts you've been talking about.
So sorry, you said down in...
Yeah, so there's some in the Wiper area, for example, some peer-to-peer trading and residential developments that are sharing electricity in between developments and things like that. So.
Yeah, I'm not aware of this specific situation, but I suppose we were looking elsewhere. Obviously, our example was coming from up into Europe. So
yeah, it's just there's some stuff locally as well, so it'd be good to You know, if you-
But it highlights that people are already doing it, and that we need to build on what's there, learn from those mistakes or what's going well, and develop a system-wide solution for New Zealand rather than pockets of different solutions.
Do we have another question out there? So while you're having a think then, I've got a question for Peter.
Yep.
So I was very fortunate enough to sit, a bit of feedback on this, Mike, very fortunate enough to sit in the Productivities Commission's working group when they developed their productivity report. I'm sure we've all seen that, came out last year. Now they had one of the independent power retailers there, I won't name it, but they turned around and said that if you sign up to our app, you can probably save instantly 5% off your bill, during a typical year. And if you actually follow the app will save you roughly about 10 to 15%. If you automate your house, we see benefit from over 20% in terms of gains. Your example you gave in terms of Norway relied on home automation. How do we make that work? How did they make it work? Is it around the smarts, the technology being available at a reasonable price, or a black box that could be put in someone's house that can realise benefit for them without them really having to think? Although I know you all out there would like to fiddle with the black box.
Yeah, I think it's a mixture of all of those things. So yes, it sometimes is installing a black box or putting some solution at the client's house. If you think of, I don't know, digital control of your water heater, the box itself doesn't cost much. It's the installation that costs to put it in. So the sort of change we're talking about here, or sort of national change, would be by having new houses going in with, say, a water heater with control. That's a different style of control to what we used to have with ripple control. Now, that could achieve what you're looking for, but it'll take time. And the same goes for replacing appliances and other things like that. But over 5 to 10 years, as you go through and do that, you have more home automation and therefore more savings.
Cool. Okay, any further questions? Chris, a mic is coming your way.
It's a beautiful looking chart with the power flowing everywhere, but anybody involved with medium voltage networks struggles to see the power flowing in all directions because our networks aren't designed for it to flow in all directions, with the protection flowing uphill and the switches and the...
Yep.
How does
That's
it work?
Right. How do you get it work? Well, the first thing is you need to add measurement. Now, I saw Robert somewhere. I can't quite see him yet. Anyway, there are solutions now that you can retrofit to your transformer to get some view on that power flow and understand what's happening at those transformers. And from a distribution company point of view, you need to understand what's happening. Now, whether that becomes a distribution system operator level of approach, or whether it's simply having a better understanding of what's happening at the LV network level, you've got to be able to see before you can make decisions.
I don't see changing thousands of offload switches to circuit breakers happening anytime soon.
No, it is going to take time. You are right.
Good. Any further questions?
Hi, Peter. Thanks for that presentation. Just picking up on your observation about Microsoft and your comment about, I think you said they're one to watch or something to keep an eye on, these guys coming into our domain. And look, I think it was last week or the week before, Facebook released or announced that it was going to launch a cryptocurrency to reach its 2 billion users. And it sort of sent, the regulators into a tailspin wondering what to do about it. I guess the question is, what would be the reason for one of these kind of GAFA companies, Google, Amazon, Facebook, why would they come into the power industry?
So,
I mean, just a little bit more context.
yeah.
From a cryptocurrency perspective, it kind of makes sense because they want to dominate transactions. They already have a kind of a platform to sell stuff. Does the same argument exist in the power industry, do you think?
Not specifically the power industry, but I think your comment about platform makes sense. So Microsoft has a platform, a software as a service, Azure platform that they want to see used, and they want to clip a ticket every time it's used. So they're looking for transactional business or economies areas where they can use that to deliver services and clip the ticket. So that's part of their motivation for being involved. At the lower level, you're looking at security, you're looking at how we're actually going to achieve it in a suburb level. But from the point of view of why Microsoft would look at that, why a Facebook or Amazon, it's about selling their services.
Very good. Any further questions? Yes, question in the middle.
Brad Henderson. I've got a bit of a big picture question for you, and it's to do with fragmentation of information and what we believe is real. We have people in this audience who don't believe in global warming, for example, or deny its existence.
Yes.
And this is kind of a microcosm of society. We see this happening everywhere. So in our industry, how do we fight the misinformation and the denial? What do we do as professionals to make sure that people understand our industry and can approach it from an informed perspective?
Well, I think I saw one of our awards people was trying to train, or at least be out there enough to tell digger drivers and other tradies how not to break power lines. And they did that by communicating in a way that actually got to the people that they were after. So they were, talking at their events and their information. So we tend to sometimes sit back and don't say much. And I think we need to be a bit more out there in the way that we present our information. And whether we believe in climate change or not, we certainly do have physical changes that we're noticing around our country that are impacting that. Now, whether that's washaways or other issues to our transmission lines and distribution lines, it's affecting the system that we have to manage, and we've got to deal with that. But to go back to your question, I think the best way is to start communicating, and I'm not sure if we do that particularly well.
Cool. Any further questions? Before Peter leaves the stage, I'd like to invite Richard Griffiths up to propose a vote of thanks.
Thanks, Peter, for a very prescient reminder of the technological change that we've all seen over the last few decades, and in particular the last couple of years. And I can't help think how exciting it is in terms of the future change that's ahead of us, particularly when you overlay that with the social and political change and the environmental challenges ahead of us. These make for particularly exciting times, and I really appreciate you getting up and giving us a bit of a heads up around what's ahead of us and the opportunities there. And together with Vic's presentation, it does make a very exciting time for us as engineers who are obviously very focused around efficiency and avoiding waste and dealing with the environmental challenges. So thank you very much, Peter. Much appreciated.